I'd like to add a quick word of warning regarding using the attribute noise for our low frequency broad shapes. And that's because this attribute noise is an additive process. You can see it's additive based on that mode here. And because it's adding noise to the point positions, it can distort and suck in the sides of that cutter mesh. Now that's not really a problem unless these distorted sides dip inside the area that we're trying to cut. Now if this mesh was located a little bit more to the side, potentially if we had a really large amplitude on this, yeah, maybe that dip would go into the mesh. It looks like it won't be a problem very often, perhaps practically never, but we're going to have to experiment with this a bit to see if that problem really arises. If that problem does seem to arise a non-negligible amount, then you can use the mountain instead for your low frequency shapes. I'll turn those octaves down to 2 so it looks more like a similar broad level of detail. And the difference here is that the mountain is just displacing the mesh along its normal direction, so it shouldn't really distort the borders of that mesh nearly as much. You can see how that's more or less preserving it. The attribute noise is kind of pushing and pulling those edges around. So feel free to revert to that mountain if the attribute noise proves problematic. As I mentioned before, it takes a little bit more work to set up the offsets on the mountain SOP, but if you'd like, you can also use an alternative setup in VOPs. So if you drop in a point VOP, we have this displace along normal node, which will do something pretty similar to what the mountain SOP is doing. You can see here it's preserving the edges of our mesh pretty well because it's just, pushing these points along their normal direction. And the way this works is we just connect our global position to the point position of that displace along normal, and we'll output that displaced position to the output P. And then we can also just wire our position into the position of any noise. Here I'm using a unified noise. It's a simplex noise, the same as our mountain and attribute noise. There are lots of other noises you can play around with in here if you'd like. Anti-alias noise works pretty well. There's a turbulent noise, a voronoi, and lots of options in here. The nice thing about this VOPS setup instead of the mountain is that you can use that same vector offset attribute for the noise in here. To bring in that external attribute, you can just create a bind node and specify the name of the attribute you're importing. In this case, it'll be offset. And you can connect that attribute to the offset of the noise. And this will allow you to create that per cutter offset in SOPs rather than using a slightly more annoying setup that the mountain node would require. And the fact that we have so many different ways to solve a problem in Houdini is one of the things that makes it so powerful and the reason why we all love it so much, and you'll find yourself refining your workflows as you develop them over time.